Welcome Algebra 2 class. Today we're going to look at solving radical equations with variables on both sides of the equation or radicals involving more than one radical. When solving radical equations that need to be raised to an even power and a variable is both outside and inside the radical, solutions that are obtained sometimes don't check. So we're always going to check those solutions in the original equation. What happens is we get what are called extraneous solutions. Solutions that work somewhere down the line but don't check in the original. So let's start by solving the equation x plus 1 equals the square root of 7x plus 15. We already have the radical isolated on one side of the equation, so we're going to undo this radical by squaring both sides. So let's take and square both sides of the equation. A square is going to undo a square root. So on the right side of the equation, we're left with just 7x plus 15. On the right side of the equation, we have the binomial squared, so we have to multiply that out using first, outer, inner, last, and we would get x squared plus 2x plus 1. We have a quadratic equation, and anytime we have a quadratic equation, we solve by getting one side equal to 0. So let's subtract 7x and 15 from both sides of the equation. That leaves us with x squared minus 5x minus 14 is equal to 0. Now we have a quadratic equation, and we solve it by factoring. So x and x, factors that multiply to negative 14 and add to negative 5 are negative 7 and positive 2. Setting each factor equal to 0, we get x equals 7, or x plus 2 equal to 0 gives us x equals negative 2. Now we have to check to see if they actually work in the original equation. We have that problem because in the process of squaring both sides of an equation, anything that might have been negative becomes positive, and we end up with possible solutions that don't work in our original equation. So let's check each one of these solutions. Let's check 7 into the original equation. So we get 7 plus 1 equals the square root of 7 times 7 plus 15. Let's see how that works. So here we have 8 is equal to 7 times 7 plus 15 is 49 plus 15, which is 64. So yes, we get 8 is equal to 8, and that one checks. Now let's check x equals negative 2. Substituting negative 2 in, we have negative 2 plus 1 is equal to the square root of 7 times negative 2 plus 15. So we end up with negative 1 is equal to the square root of negative 14 plus 15, or 1. Negative 1 does not equal 1, and so x equals negative 2 does not check. The only solution then is x equals 7. Let's do another example. This one has to work with a cube root of an equation. With a cube root of an equation, we don't have to worry about extraneous solutions. However, we notice that we have both radicals on the same side of the equation. In order to solve that, we have to have one radical on each side of the equation. So let's add the cube root of x plus 7 to both sides of this equation. That gives us the cube root of 2x plus 5 equals the cube root of x plus 7. Both of these are cube roots, so to undo that, let's take both sides of the equation to the third power. The third power undoes the cube root, so we're left with 2x plus 5 equal to x plus 7. And now we have just a linear equation to solve. Subtracting x from both sides gives us x plus 5 equals 7, and then subtracting 5 from both sides gives us x equal to 2. For our next radical equation, we're going to look at an equation that has a radical on each side of the equation. In this case, the squaring process is going to need to be done twice. Remember, to start, we always want to make sure that we have a radical on each side of the equation. So on the equation that we have here, we have the square root of x plus 2 on the left side and the square root of 3 minus x on the right side. We also have an additional term on the left side, a plus 1, that's outside the radical. Just like the previous example, we're going to start by getting rid of the radical by squaring both sides. So in this case, we are going to square the binomial x plus 2 under the radical plus 1, and on the right side, the square root of 3 minus x quantity squared. On the right side, life is easy. The square root is undone by the square. But on the left side, we have a binomial that needs to be squared. So to see that, let's go ahead and write out both binomials. We have this under the square root, we have x plus 2, and then we have plus 1 multiplied by itself. And as we said, on the right side, the square root is reversed or undone by the square. So we have just 3 minus x. On the left side, we have a binomial, so we're using FOIL. So we're going to do first, we're going to take root x plus 2 times root x plus 2, which leaves us with x plus 2. Then we're going to do outer, which is root x plus 2 times 1, so that gives us a square root of x plus 2. The inner is the same value since we're squaring. The outer and inner are the same. So we have another 1 times root x plus 2. In our last term, 1 times 1 is 1. On our left side, we have some like terms we can add together. The x is on its own, but 2 plus 1 is 3. And our two roots are like roots. There's 2 of them, so adding them together, we get 2 times the square root of x plus 2, and that equals 3 minus x. Now we're ready to go back basically to the beginning and start again. We want to get one radical on each side of the equation, or isolate the single radical that we have left. So here's the radical, and we want to get it by itself. So we need to subtract x from both sides, and we also need to subtract 3 from both sides. We're left with 2 times the radical x plus 2 equal to negative 2x. At this stage, we have an option. We have a coefficient here of 2 multiplied by the radical. We can divide both sides by 2, and we only want to do that if it divides both sides evenly. In this case, if I divide by 2, I'm going to end up with just negative x on this side, and so it's a good idea to go ahead and divide both sides by the 2. Now we're going to solve this radical equation by squaring both sides of the equation. So we're going to square both sides. We get x plus 2 is equal to x squared. Getting one side equal to 0, we have 0 equal to x squared minus x minus 2. This will factor into x minus 2, x plus 1. So we have two solutions, or two possible solutions. We have that x minus 2 equals 0, so x is 2. Or we have x plus 1 is 0, so x is equal to negative 1. Just like in example number 1, we have the possibility of extraneous solutions because we have a step, in fact we have 2 steps, where we squared both sides of an equation. When we square both sides of an equation, where we could have had a negative equal to a positive, once we square them, both are positive, and so that gives rise to extraneous solutions. So let's come back and let's check each one of these solutions. Let's start with checking x equals to 2. substituting it into our original equation. Always, always, always substitute and check in the original equation. So we have the square root of 2 plus 2, outside the root plus 1, equal to the square root of 3 minus 2. So we end up with the square root of 4 plus 1 is equal to the square root of 1. Or we get 2 plus 1 equals 1. I don't think so. This one doesn't work, so x does not equal 2. It does not work. Now let's check x equals negative 1. Again, we're going to substitute into the original equation. So we have the square root of negative 1 plus 2, outside the root plus 1, equals the square root of 3 minus negative 1. So we end up with the square root of 1 plus 1 equals the square root of 4. 3 minus negative 1 is 3 plus 1, which is 4. So we end up with 1 plus 1 equals 2, and that makes more sense. This one checks. So our solution is x equals negative 1. Let's do one more example like that. In this case, we again have one root isolated on one side. In this case, it's on the left. And on the right side, we have a binomial 1 plus the square root of x plus 1. So again, we're going to square both sides of this equation. So we have the square root of 2x plus 3 quantity squared equals the binomial 1 plus root x plus 1 quantity squared. On the left side, the square undoes the square root, so we have 2x plus 3. On the right side, we're going to have to multiply it out using FOIL, or if you know the pattern of special product of binomials, a binomial squared, we could use that rule. But let's go ahead and just write out both binomials and go through FOIL. So first, and then we have our outer and our inner, which are both the same. They're both root 1 times root x plus 1. And we have 2 of them, so I have 2 of root x plus 1. And then last, we take root x plus 1 times root x plus 1, which is just x plus 1. Now let's go ahead and combine like terms, this time on the right side of the equation. We have an x, we have a 1 plus 1, which is plus 2, and we have 2 root x plus 1. So we had the x, we had the 1 plus 1, which gave us 2, and then we had the 2 root x plus 1. Again, we need to take and find or to isolate the radical term, so we want to get this term by itself. So let's go ahead and subtract x from both sides and subtract 2 from both sides. We end up with x plus 1 equals 2 times the radical of x plus 1. We could divide both sides of this equation by 2, but if we did that, we would end up with fractions on the left side of the equation. We'd end up with 1/2 x plus 1/2. And since we don't want to deal with fractions, let's go ahead then and just leave the 2 on both sides, and we're going to square both sides at this point. So on the left side, we're going to square the binomial x plus 1, and on the right side, we're going to square the single term 2 times the root of x plus 1. On the left side, we have FOIL. Using FOIL, multiplying this out, we get x squared plus 2x plus 1. And on the right side, I have a single term composed of 2 multiplied by the square root of x plus 1. When I square that, each term gets squared. So 2 is going to be squared to get 4, and the root x plus 1 is going to get squared to get x plus 1. So we'll have 4 times the quantity x plus 1. Let's go ahead then and solve this quadratic equation. We have x squared plus 2x plus 1. Distributing, we get 4x plus 4. getting one side equal to 0 by subtracting 4x and 4 from both sides of the equation. We get x squared minus 2x minus 3 equal to 0. This quadratic will also factor, so let's go ahead and do that. X times x for x squared, negative 3 times 1 to get the negative 3. And those two in the inner and the outer terms add up to negative 2x. So we have two possible solutions. We have x minus 3 equal to 0, so x is 3. Or we have x plus 1 equals 0, so x is negative 1. Now let's go back and check our answers. Again, the check has to be done in the original equation before the squaring process occurs. So let's go back for our check. Let's check x equals 3 first. Substituting 3 in for x in the original equation, we have the square root of 2 times 3 plus 3 equal to 1 plus the square root of 3 plus 1. On the left side, we have 2 times 3 is 6 plus 3 is 9, so we have the square root of 9. On the right, we have 1 plus the square root of 4. So we get 3 equals 1 plus 2, and that checks. X equals 3 is a solution. Now let's check x equals negative 1. Substituting negative 1 in for x, again in the original equation, we have the square root of 2 times negative 1 plus 3 equal to 1 plus the square root of negative 1 plus 1. On the left side, we have 2 times negative 1, negative 2 plus 3 is 1, so we have the square root of 1. And on the right side, we get 1 plus the square root of 0. So 1 equals 1. That one also checks. This time, we have two solutions. And that's our lesson for solving radical equations.